Hey, Brady, I hope you're doing all right. You might be having surgery like right now.
What's up?
Yeah, so hopefully you're doing okay. I don't know. Having good dreams. Here's the homework for R7. And there are only 6 problems because applications of equations means story problems. Yay! So there's 6 problems for homework and that is all, right? Okay? All right, they start us off with this equation, which is the equation for, write this down, simple interest. The way of calculating simple interest, not interest that compounds, we'll get to that later, but simple interest is equal to the principal.
It's pert.
Times the rate, it's not pert. Times the rate times the time, okay?
Pert has E in it.
Yep, pert has E in it, yep. Which is compounding, that's continuous compounding interest, right? So simple interest, starting with the principal, how much time is elapsed, and then what the interest rate is. So here we have a principal of 5,000 at 4%, which we have to convert to a decimal, right? And then for 1.5, probably years. Unless they specify otherwise, your time period will always be in years. It may be in months, but they will specify that if it's not years, okay? And so your interest will be $300 if you have that going on, right? Simple interest, 4%, 1.5 years for 5,000. That means the interest will be $300. Good? All right, example 1, let's pull stuff out. Imani, I think I pronounced that right, invested 8,000. What is 8,000? Principal. That's the principal that I put in, right? Okay, so I'm going to put a big P there. And it was invested for 2 years. That is time. In a stock fund that earns 6.5% simple interest, that is your rate. But I'm going to put it as a decimal. What's 6.5%? 0.065. Don't forget the 0 there. Yep. The remaining money put in an 18-month CD that earned 0.8% simple interest. If the total interest from both investments was $804. So here's the deal. We've got another time and another rate, and this rate is 0.8%, and this 0.8% as a decimal is 0.008, right? So I've got 2 rates and 2 times, because here's what's happening. This $8,000, we're putting part of it in one and part of it in the other. Now, does it say that we're doing exactly half and half, like 4,000 here, 4,000 there? No. So we have to decide what we're doing. So this is where it gets a little bit more intricate. We've got something here is adding to something here to give me my overall total interest. What's the overall total interest that I'm earning off of that? 804, right? Okay. So this is my interest here. Okay. This is this guy's interest plus this guy's interest equals the total interest, right? Okay. But interest is calculated as principal rate time. Principal rate time. Okay, so I've got 3 parts going in each little blank over here. Principal times rate times time. Principal times rate times time. Got it? The first one is going in for 2 years, so my time is going to be 2 at 0.065. Do you see how that works? Principal rate time, I put 0.065, 2 years.
Why don't we make the 2 years into months?
I'm gonna make 18 months into years. What's 18 months in years? 1.5. Correct. We do need to put them in the same units, but I would rather have them in years first. Okay. So 1.5 years is the second one at 0.008. Yeah. Now here's the tricky part. I don't know what principal I'm putting here and what principal I'm putting there. No clue. But I do know that they both have to add up to be 8,000, right? So let's say I'm putting X amount here. How much am I putting here? Because X and X would mean they're both the same, right?
Why?
Let's say I put 2,000 here. How much am I putting here? 6,000, because what'd you do? 8,000 minus whatever you put in the other one, right? So if this one is X, that one's 8,000 minus X. Could you do it the other way around, have this be X and this 8,000 minus X? Sure, right? So now we're going to do the math, okay? So if I multiply all 3 of these together, 2 times 0.065 is 0.13, I think. And that times X is 0.13X. So those all combined is 0.13X, right? Okay, 1.5 times 0.008, I don't know, is 0.012. 0.012 is these two combined, right? Then I have to do what? distribute that through, okay? So what is 8,000 times 0.012? I can't math. Like 96. 96.
Wow.
Ah, look at that math.
Crazy.
Look at that. 8 times 12 is 96, and so I just have to figure out the decimal, right? Minus, and 0.012 times x is 0.012x, right? Equals 804. Now we combine. Now, do you see how many pieces we have at this point? How many pieces do we have? 3 on the left, right? And 1 on the right, so we have 4 total, right? But these two can go together because they're like terms. 0.13 minus 0.012 is like 0.118 x. Yeah? 0.118x if we combine these two, right? And then I'm going to toss the 96 to the other side. So I'm going to subtract 96. And that is equal to 708. I don't know. I don't know if I did that right. 708. Okay, now I can't divide. This is the only thing I can't do. 0.118 divide by 0.118. I cannot do that.
Come on.
I can't even pretend I can do that.
6,000.
6,000, yeah. All right, so 6,000 goes into where? X, and X is which one? The 6.5, that is in a stock. Okay, so my stock was 6,000, and the other one is going to be how much? 2,000, and that's going into what? A CD. So CD is 2,000, and a stock is 6,000. You see what we just did there? Okay, we just have two interest rates, or principal rate time, okay? So yes, it's involving this equation, but it kind of makes it a little bit more tricky because we're trig kids and we're big brain, right? No. Okay. All right, this was a mixture problem involving interest, right? Those are kind of intricate. Setting those up, ooh, oy vey, that's a lot. Okay? All right, I love these. These are mixture problems. You guys have heard like the, how much of a 10% solution do I need to add to a 20% solution to make a 15% solution? Oh, is this physics maybe? Maybe not. Maybe it's chemistry. Chemistry more. Okay. This is not bad though. Okay, so we're mixing stuff together.
Physics isn't going to have a class.
I don't know. We might put them along a string and like instead of making the string fastened there, fastening the string there. I don't think so. We'd burn them up. We'd shrink them. Yeah. I don't need any more catastrophes in this room yet. Okay, all right, mixture problems. We're mixing things together. So, household bleach. Household bleach contains 6% hypochlorite. That's 6%, so 0.06 is what I'm going to write down. That is his concentration. How much household bleach should be combined with 70 liters of a weaker 0.01 hypochlorite solution to find a 2.5%, which is 0.025, okay? So the way that this works is we have two things that are being added together to make our result, right? Okay?
You got to find the mole.
We have... Within each one of those blanks, we have the concentration times the amount. And the concentration times the amount equals the concentration times the amount, right? So the first concentration I have is 0.06. 0.06 concentration. And I do not know how much I am adding. So let's just leave that guy blank, right? The second concentration I have is a 0.01. And how much amount of that do I have? 70. So I do know what that is. And I want ultimately a concentration that is 0.025, and I don't know that amount, right? Okay? So what we're ultimately trying to find is this guy right here. I don't know what this amount is, right? So I'm going to put X there. What will my overall amount be?
70.
Yeah, absolutely, right? X plus 70 is what will end up being the answer at the end, right? Look at that. Easy peasy. Now it's just the same as what we were doing before, right? 0.06x plus 0.01 times 70 is like 0.7, I think.
Yes.
0.7 equals, I'm going to distribute that 0.025 through. So 0.025x, what's that times 70? I don't know.
1.75.
1.75, okay. There is that. Now we have 4 pieces again. It's easy at this point, right? It's decimals, like it's not very nice, but let's move the minus 0.025 over to this side because that's going to make him positive, right? Okay, and that's going to be like 0.035. Is that true?
Yeah.
X, okay. Then I'm going to subtract my 0.7 over here. minus 0.7, and that's going to be equal to 1.05. Yeah? And then
4.
divide by 0.035.
Actually, I think it's 3.
It's 30.
30 liters. Okay? So my overall total solution will be how many liters? 100, right? 70 liters, 30 liters, okay? Concentration times amount, got it?
But they want
Yeah, so how much household bleach should be combined? So 30 is the answer, right? I was just giving it an extra, like, how much will we have at the end? 100, yep. Okay? Good? Not so bad. Just, like, set up the equation logically, all right? That was example 2. Okay, now I gotta really be on my game here. I'm gonna open up the book so I don't lead you astray because some of these they set up kind of weird. So hold on just a second.
Don't ruin my book. It doesn't have a cover on yet.
Yeah, I know. You should fix that.
It'll be
Chapter
fine.
R. Chapter R. All right, we are on example 3. Oh, and we're on R7. We're on R7. Number 3. Okay, here we go. All right. Alina takes a boat 6 miles downstream with a current of 1.5 miles per hour. The return trip against the current takes 1 hour longer. Right? Takes 1 hour longer. Okay? All right, find the speed of the boat. We know this, right? Distance equals rate times time. But also we could rearrange that and we could divide by r to get time is equal to distance divided by rate. True? Okay, now, here's the deal. The distances should end up being the same, right? The distance, no matter what, is 6. Okay, we're not contesting that. It's 6 miles down, 6 miles back, right? But it doesn't take the same amount of time. So let's do this. Let's set this up so that we have time over here and time over here. But the rate going or coming back is 1 hour longer than what we're going. So let's see, the return trip, this is the return trip. Okay? If this is the return time, I have to add 1 to this side in order to be the going trip, right? I have to take the going trip, add an hour to be the return trip, right? The return trip is longer. True? Right? If the going trip is 5, then the return trip would be 6. The return trip is 1 hour longer than the going trip. True? Okay? So that's how we're going to set that up. All right, now time is equal to distance divided by rate. Plus 1 is equal to distance divided by rate over here, right? So we have a distance divided by rate, and we have got a distance divided by rate, okay? What's the distance for each one? Distance, rate,
6 miles.
distance, rate. 6 miles, so I'm going to put a 6 on the top of each one, all right? The rate. I'm going to be rowing at this. Are we rowing? What are we doing? Rowing? I'm going to be rowing at the same rate, but if I am going, I am with the current. So I am going to be, let's call rate. If I'm going with the current, it's going to make me feel like I'm going 1.5 miles faster than what I'm going, right? It's my rate. So if I'm rowing at 10 miles per hour, it's going to make me feel like I'm going 11.5 miles per hour, right? But the return trip, since I'm going against the current, if I am going 10 miles per hour, it's going to make me feel like I'm going 8.5 miles per hour, right? Because I'm subtracting that, okay? So this is where it gets kind of ugly. Here's my equation. Let me get rid of my distance, rate, all that stuff, right? So we have this guy set up so that we have time plus 1 equals time. That's what we're starting with. But time is distance divided by rate. Distance divided by rate, okay? Now, we need some common denominators. This is over 1, right? Oh, boy. Oh, boy. What's your common denominator going to be?
I don't have enough room for this.
I know. Make some room. Okay? I need to multiply. My common denominator is going to be r plus 1.5 times r minus 1.5. Now, hold on just a second. The bottom's going to cancel off anyway, right? We know that. So we just got to get to that point. R plus 1.5 and r minus 1.5. So I'm gonna write all my bottoms out. My tops are 6, 1, and 6, and then I'm gonna multiply by what they need. Here's gonna be in green. What he needs in green. What he needs in green. Zip. Okay, do you see what we just did? Questions on how we set the equation up so far? We're doing good? Good. Good. Very good. Okay? All right, the first one, he is missing a what? R minus 1.5. Okay? The second one is missing all of them. So I'm going to multiply by both of them. R plus 1.5 and R minus 1.5. Okay? But that's going to end up being a difference of squares. We'll FOIL this together here in just a second. So that's fine.
You can just get rid of the whole middle section then.
Correct. This all cancels that to be 1, which is the point. But we want to put them under, we want to like be able to put them all under one roof. So that's why we're doing it. Right? Okay? So this one needs an R plus 1.5. Okay, now the bottom cancels off. Makes it a little bit easier, right? And now we have to simplify some stuff. So 6 times, I'm going to distribute this through. 6 times R is 6R. 6 times 1.5 is 9. Yeah? Okay, that's that first piece, right? 6R minus 9, that's 6R minus 9, right? Okay, now we've got to FOIL this. This is a reverse difference of squares, right? Okay, so we've got plus R squared. Now then we'll have minus 1.5R plus 1.5R. So the O and the I will cancel out. So then I need minus 2.25 is what 1.5 squared is. Or 1.5 times 1.5. You see where we're at now? Okay, that's that second piece. Equals
6R plus 9.
6R plus 9. Okay, now this is going to be beautiful. All right, we've already got it like way far down, right? Like the bottom's canceled off, we've got it way far down. Now this is really exciting because let's do some things. Let's
Move it all over to one side.
no, I don't want to move it to one side because I'll show you real quick. If I subtract this 6R and subtract this 6R, check it out. My R is gone. All I have is an R squared and a bunch of other junk. So now, let me put together what I have left over. R squared, if I combine the 9 and this negative, this is minus 11.25 equals 9. Yeah? Now what do you want to do? Now I don't want to get everything to one side. I want to bump this 11 to the other side because then I can take the square root and be done, right? So I've got R squared is equal to 20.25, and then I take the square root. Now, is it plus and minus?
Yes.
Technically, we put the square root in there, but what are we talking about?
4.5.
We're talking about a rate. Can you go like a negative 60 miles an hour? No. So it's just positive. We are rowing at a rate of what?
4.5.
4.5 mph. That is how fast I am rowing. That is my rate. Got it? Oofda. That was a lot. Was that enough for the day?
We did half.
Yeah, we did half. That's half. I'm okay with that if you want to stop there. That's okay. Okay, we should be able to go to solve applications involving rate of work done. Rate of work done. Up through 20.
What were the numbers
So
again?
just
So half. Those first 3. 8, 10, 14. Here they are. Do you want me to go back down, Casey? All right, did you get that written down? 8, 10, 14. Do those for homework. Do those right now. Go. All right, I'm going to stop the recording for